Hello, we are going to start section 11-3. I'm going to share my screen like always. And we will begin. Get this cleaned up a little bit. And today we're talking about what's known as combinations, and that's why this is in red right here. And in green. Permutations is what we did in 11-2. And it was written with an N, a P, and an R, where you would have 10 things and you are choosing 3 of them. And in permutations, order matters. Okay, combinations are what we're talking about today. And in combinations, the order of the items makes no difference. And that's what's written right there. And the formula that we use is given right here. And again, we do not use our formula. It reminded me that I wanted to open up my calculator real quick because I forgot about it. Now I have my calculator. And in my calculator, excuse me, remember in this, it is math, and then probability is the tab we're looking for up here on top. And we did NPR yesterday, and today or on our last lecture, this lecture we're talking about combinations, which is NCR. Okay, very similar, but in the permutations part, if I had 10 people and I wanted to choose a vice president or a president, vice president and a secretary, the order in which I choose these people matters because the same person cannot be president, vice president, and secretary, or it's going to be 3 different people. But those 3 people could be any of the 3, and it's different. So you could have John, Mary, and Susan as president, vice president, and secretary, or you could have Mary, John, and Susan, and that's a different set of president, vice president, and secretary with the same 3 people. That's why order matters in that. In combinations, written in similar way, NCR, that's that formula right there again. Okay? And on our calculator, it actually says NCR. But with combinations, the order of items doesn't make any difference. So if I have these 10 people and I'm going to make a committee of 3, whereas in the permutations, I was making a president, vice president, and secretary. In a combination, I have a committee of 3. That means that the order doesn't matter. That means that if I've got my same people here and these 3, this is the same committee, even though I've listed the letters different. So the order here does not matter. But we have this example right here where it says a 3-person committee is needed to study ways of improving public transportation. How many committees can be formed from 8 people on the board of supervisors? Well, that is a committee where order doesn't matter. So I do 8C3. I grab my calculator. I'm already in my probability mode. So I'm going to choose choice number 3 or down arrow to that. And I get my N is 8 and 3. enter. So there are 56 ways to make a committee of 3 out of all of those 8 people. Very, very simple, very straightforward. In a poker game, a person is dealt 5 cards from a standard 52 card deck. The order in which the 5 cards are received does not matter. How many different 5-card poker hands are there? Okay, let's just take, for example, this poker hand that maybe has a 2, 5, queen, queen, and oops, that should have been a box. 8. That's one possible 5-card poker hand. Okay, one of many. Okay, but it doesn't matter what order I hold these in my hand. I can do queen, 2, 5, queen, and 8, and it's still the same poker hand. That's what it means when order doesn't matter. So I've got 52 cards, and I'm going to choose 5 at a time. And again, I just go back to my calculator and go to the permutation in the probability part. Number 3, actually, I'm going to the combinations, sorry. Combinations, and then this, I've got 52 for my N, and I am going to take 5 at a time. And there are 2,598,960 different 5-card hands that I can have with those 52 cards. That is how, and what we're leading into is the probability part of this chapter. That's how we determine what hands are strong in poker and what hands are not strong in poker, or are not as strong, is by finding out how many possible ways a hand can be made. This set that I gave over here has 1 pair, which is a relatively strong hand, but it isn't the best. If I had 3 queens, that would be even better, obviously, and so on and so forth. That's how you figure out probability of cards, and that's how you determine who wins in poker. With that, that's all you really need to know for combinations, is that order does not matter, and know how to use your calculator. Remember, if you're using your calculator and you don't have the new TI-84 Plus, if you have the old TI-84 calculators, then you are going to press 52. I'm going to make sure I'm doing this right. And then you go to math, probability, oops. And 3 for combinations, and it does 52, and then it says NCR, and then you push 5, enter, and it will give you that same number of 2,598,960. With that, I will be back to do the next video here in a few. I hope everything's going well and you're keeping up with everything. Have a good one.